let's see.
Yeah. All right, I continue again. So before this, Mr. Ramli Muhammad Osman work with a Mineral Research Center under GMG, Department of Mineral and Geoscience Malaysia in Ipoh. And then he received his degree, BSc, in 1993 from University Malaya, Malaysia. And then after that, as a fresh graduate, he involved with the what we call it stability analysis of alluvial mine slope phase. So you can imagine from fresh grade already involved with the stability analysis. And then from 1984 to 1985, he put here in CV as geophysics and software programming, programming. And then he joined with the University of Science Malaysia, USM. And of course, he have some familiar with the ABEM thermometer SAS 300 to delineate aquifer in Perlis. And then he tried to determine groundwater level, thickness of overburden, and depth to bedrock to establish stable mine phase, right? And then he also with the programming using basic language for working with digitizer and calculation of volume and area of solid body. I believe this one maybe reflect to the or body maybe, right? So next from 1986 until 1988, he involved with the deep alluvial drilling project as a head of unit, all right? And then that project is located at Kampung Kancun Darat, Banting, Kuala Langat, Selangor. You receive, Atira, the file?
Not yet. Now,
Not yet.
now I'm sending.
You try first, eh? I will continue to read your CV of speaker today. So in 1989, he worked as a all evaluation head of unit, which is he covered 2 mineral investigation project. First to determine the distribution, quantity, and
Okay,
quality
I've
of
sent it
cooling
here.
in Beidou, Perak, and number 2, distribution and quantity of alluvial gold. Okay, so not just calling. He also covered the gold in Sungai Yu, Pahang. I believe this one near to Kuala Lipis. Atira, you check the file first and then try to share the screen, and then I will quickly stop this chair session, and I will pass to Mr. Ramli. Okay, I continue again. From 1990 to 96, environmental monitoring and impact study head of unit. I believe this one should be related to the EIA maybe. And he set up facilities for environmental monitoring, monitor the discharge of wastewater from mine and mineral processing plants, and ecological survey of ex-mining land. And number 5, he also covered identification of hot spring area in southern Peninsular Malaysia for geothermal and tourism development. This one interesting. So maybe he will share later, especially when talk about spring. I'm interested. Then he received his master 1996 to 1998 from Colorado School of Mine, USA, in environmental science and engineering. Then 1998 to 2001, he worked as environmental monitoring and impact study head of unit. He covered about the heavy metal distribution and absorption into terrestrial and aquatic plant in edge mining. So more or less focus on edge mining. And 2002 until 2010, he worked as a rehabilitation of quarries head of unit. So he set up herbarium facilities. Oh, now become botanical survey of limestone hill and preparation of herbarium specimen. And then identification of herbarium specimen in Malaysia National Herbarium at FRIM Forest Research Institute of Malaysia. And number 4, he set up the rock climbing facilities, held several rock climbing rope technique workshop to recruit men and women to participate in the rehabilitation project. Wow, very interesting, yeah. And then number 5, he involved in research for revegetation of limestone quarries. You know, sometimes we clear all the rock cliff, bench, and so on. So Mr. Ramli involved to green back all the slope face maybe. Okay. And then maintenance plan stock in nursery. 2011 until 2015, he involved with the geospatial analysis of ex-mining land in Malaysia as a head of division, which is he developed a digital database on the distribution of ex-mining land in Malaysia. So he covered all the Malaysia. Then number 2, he studied the geospatial information on the development of ideal ex-mining land in Malaysia, which include the geospatial analysis of current land use, distribution of ex-mining land, geology, which is cover the lithology and distribution of metallic and industrial mineral resources, and location of mine and quarries. Okay, so that the CV that supplied to me. Atira, you have his material?
Not yet.
Not yet. So now what the status, Mr. Ramli? Still managed to share the screen maybe. Okay, Alhamdulillah, now we have almost 75 participants. Thank you everyone which spend your time to attend this technical talk. Basically today myself, Hariri, you can call me Hariri, as a current president for Geological Society of Malaysia. I at Sungai Hot Spring. Basically I have workshop here. So we have 2 sessions basically for our today's session. Hopefully we can spend 1 hour first for first session with the starting of information from Mr. Ramli. Hopefully he managed to share the slide very soon. So first topic basically cover welcome to Australia in the world of geology and geographical perspective. All right, and then he will continue with a brief introduction to geology of Australia. So we are very lucky this person will share about the geology of Australia. And then so he will cover a brief introduction of geology, focus with the western part of Australia. And then after that, we have part 2. We take a break and then we continue with the part 2, 12 noon until 1:30 p.m. He will cover about introduction to the geology of Southwest Yilgarn Craton. And then second topic is appraisal of the geology of Boya Quarry. So hopefully everyone can take this opportunity to learn with the our speaker today, Mr. Ramli. Now the slide is ready. Okay, Mr. Ramli, you are ready or not yet? Mr. Ramli, are you ready? Yeah, most of you give some of comment. For me, it's not easy to spend your time, your energy to work with our beloved GSM society. Some of us like to comment, to say everything, but yeah, everyone have their own time and energy to spend. So welcome to GSM. Join as a maybe not just a council member, maybe just a student member or life member, support us. All right. And of course, you can offer yourself to become a speaker and try to handle this event smoothly without any stuck problem. All right. Mr. Ramli, are you ready? The slide is ready, but where is Mr. Ramli now? Let me check with him first.
All right.
Mm.
Sorry, I hear you. I cannot. Well, is the slide on?
Yeah, yeah.
All right, the slide is on.
Okay.
Or slide is on, but I cannot.
This from your screen or Atira screen actually?
Mr. Ramli screen.
Okay. So set up for the full screen maybe, hopefully. Okay, nice.
Excuse me, people. Good morning. The presentation is on the appraisal of geology of Boya Quarry in Western Australia. Can I see my face? Yeah, there you go.
We have
I'm
now 81 participants, Mr. Ramli, waiting this night actually. It's okay. Everyone have their own problem and struggle
ah,
to deliver. I'm
I'm
okay
I'm
with
I'm
everyone.
familiar with participating rather than what I call this presenting. Okay, let's just start. Um,
Inshallah.
let's just start. All right. Good morning, everybody, and the presentation is on appraisal of geology of Boya Quarry in Western Australia. And how to, oh my God. Now, this the appraisal of geology of Boya Quarry is a follow-up of Boya event in Perth, Western Australia. This is the group photo participant at Boya Quarry. There are about 35 participants in all, excluding me. And in Noongar language, Boya means rock. Noongar is the Aboriginal people that live in the area. And Boya Quarry means rock quarry. Boya Quarry consists of 5 quarries that once supplied hard rock aggregate to Perth. Acknowledgement of a country in Australia, um, it is customary for official function. For example, the recently held Australian of the Year, Australian citizenship ceremony. The organizer would acknowledge would recite the acknowledgement of country. Likewise, the what do you call this? The face-to-face technical talks, workshop, and also webinar attended in Australia. The presenter would acknowledge would recite the acknowledgement of country. So being here, being in Australia, I would also would like to recite the acknowledgement of country. I acknowledge the Australian Indigenous and Torres Strait Islanders people of this nation. I acknowledge the traditional owners of the lands on which I conduct this webinar. I pay my respect to ancestors and elders past, present, and emerging. Now, this is the flag of Australian Indigenous people, and this is the flag of Torres Strait Islands people. Before I begin, I would like to share something extraordinary with you. Last year, I attended 40 webinars organized by GSM, IGM, KM, BP, UMS, and others. And 9 of these engineering, 9 of the webinars were on engineering and geology. 2 of them from China, 7 on geophysics, 4 on petroleum geology, 3 on regional geology, 2 on geothermal, 2 on groundwater, 2 on hydrology, 2 on paleontology, 1 on archaeology, 1 in career in geoscience, 1 in clay mineralogy, 1 in climate change, 1 in geological disaster, 1 webinar on geospatial, and 1 on the law of the sea, 1 on quaternary geology, and 1 on weathering profile. So I thought I've attended so many webinars last year, so why not I present webinars for this year. So I really listed out, these are my proposed geology webinar for 2024. On January, I will present this Boya Quarry. Then on February, Cape Parent. This will be a nice follow-up from Boya Quarry. Boya Quarry is largely on the Precambrian geology, whereas the Cape Parent, WA, is Upper Quaternary. It is the opposite side of the geological time scale. In March, Geology of Australia, Precambrian, Geology of Australia, Paleozoic. In May, Geology of Australia, Mesozoic era. In June, Geology of Australia, Cenozoic era. July, Geology of selected places in Western Australia, 11 places. In August, cave and cast of Australia, impact craters of Australia. In June, in September, and on October, Geology of selected places in Malaysia, 13 places in all. And November, Geology of selected places, Malaysia, 13 places. And December, Geology of Bali, 4 places. Now, all these material are in my Facebook. Geology of Australia, from Precambrian to Cenozoic. There are 49 albums. Cave and cast of Australia, 18 albums representing 18 caves throughout Australia. Impact craters of Australia, 30 of them. So the thing is that these material, they are very detailed and they are very tedious. To compile them into slide would be an effort. So I do not think I will proceed with this proposal unless I have a request from the members. Regardless, I already sent this proposal to the President of GSM, Dr. Hariri, and also to Mr. Tan Boon Kong, and they agree to host today's webinar. Dr. Hariri and Mr. Tan Boon Kong agreed to host Cave and Castles of Australia, not in August, but in May. I thank them. There's a question here regarding the impact craters of Australia. Does Malaysia have impact craters? Anybody? I'm getting something.
The question for us, Mr. Ramli?
Yes.
Oh,
For the audience, does Malaysia have impact craters?
if I can answer, I will answer. Of course,
Throughout the
Lenggung.
world, there are some 200 impact craters. Impact craters are caused by asteroid impact. So we have visitors from outer space. And for Australia, there are 30. So does Malaysia have any impact craters? Any?
Yeah, we have Bukit Bunuh in Perak, Lenggung. We have Masuri Ring. But for the Paluh Ring, I'm not sure.
Yes.
Pak Chia and Dr.
Yes,
Anizan
that's
confirm
correct.
on
Yes,
that. I'm not sure.
exactly.
In Paluh in.
Exactly, that is correct, sir. So we do have impact crater, at least in Bukit Bunuh, in Lenggung. And the Struvite is actually a distinctive rock for large impact structures. However, the Earth impact database that has been monitoring impact craters throughout the world has not recognized Malaysia have an impact crater. Just saying. So the content for presentation today is part 1. Welcome to Australia. Part 2, a brief introduction to the geology of Australia. Part 2 will be on the brief introduction of geology Western Australia, brief introduction of geology of the Southwest Creighton, and finally the appraisal of geology of Boya Quarry, Western Australia. Why they are arranged in this way? Because Boya Quarry is in the Southwest Creighton, and Creighton is in Western Australia. Western Australia is in Australia, and Welcome Australia is the overall aspect of the geological and geographical perspective of Australia. So before we continue, I would like to introduce the audience to this what we call the geological chart and the geological time scale. And this is important because it is the heart and the lifeblood of the presentation. I will refer to it throughout the talk. And this geological time scale provides time framework to describe the history of the Earth. That is what I'm doing now, describing the geological history of Australia while reflecting on the geology of Malaysia. That's what is in the flyer. I shall not go into detail, but we don't have the time. The largest time division are the eons, the Hadean, the Archean, Proterozoic, and all these collectively called the Precambrian, and the Phanerozoic eon. The Phanerozoic I will refer most of it most of the time. And this eon, they are divided into era into period into epoch, and epochs into ages. And that is as much as I can say. We don't have time. Regardless, I will give you what called this a cheat sheet. Cheat sheet. Those are the sheet, the quick sheet you make to cheat in the exam. So in the presentation, I will refer to the Precambrian, to the Archean, Proterozoic eon, to the Eopaleozoic, Mesozoic, and Neo-Archean. I'll also refer to the Paleo, Mesozoic, Neo-Proterozoic, and possibly the Tonian and Carolingian Ediacaran period. Much of the time, I will refer to the Phanerozoic eon. Phanerozoic means a visible life. I will refer to the Paleozoic era, Mesozoic era, and Cenozoic era. Mesozoic means middle life. Cenozoic means new, a new life. Mesozoic is an interesting era because it is a greenhouse era. Greenhouse, hot, high evaporation, therefore it's wet, it's hot and wet. Mesozoic is also what they call the age of the dinosaurs. So at one time, much of Australia is covered with tropical rainforests. And in this tropical rainforest, there were millions of dinosaurs roaming in the forest. I will also refer to the Paleogene. The Paleogene, if Mesozoic is a greenhouse Earth, the Paleogene is a super greenhouse Earth. It is a runaway greenhouse. England were covered with tropical rainforests. Alaska, palm trees. These are the period of extreme greenhouse the Earth was experiencing. I also refer to the Paleocene, the Eocene, Oligocene, in particular Oligocene. The Oligocene is a very important epoch in Australia. I will refer to the Neogene, a period, Mesozoic and Paleozoic, also the Quaternary, the Pleistocene, and the Holocene. The Pleistocene would be Middle Pleistocene and Upper Pleistocene, which is important in the cave, the limestone and cave development in the Upper Basin. So, sorry, those that I know in this presentation, there are audience that are not geologically trained, and I have to excuse. I'm sorry to that. This what do you call? This slide is not functioning the way it's supposed to function. Anyway, the geological time scale is not linear. It's not linear. 90%, about 90% of the geological time is a Precambrian, whereas 10% of the geological time is Phanerozoic. Geological time means the time from 4.6 billion years to the present day. So 90% of the geological time is in the Precambrian, whereas only 10% of geological time is in the Phanerozoic eon. I want to make a disclaimer here. Disclaimer on the ages. For example, Silurian, this period is actually 444 to 419 mega annum, million years. Mega annum means million. But I refer Silurian as 445 to 420 mega annum. Permian, the boundary between Permian and Triassic that mark the mass extinction, where 95% of life on Earth went extinct. They also called the Great Dying Extinction. It is actually 252 mega annum, but I refer this boundary as 250 mega annum. Same thing here, the Cretaceous Paleogene boundary, the boundary that marked the extinction of the dinosaur and 80% of life on Earth. I would refer it as 65 million years instead of the 66 here. And most important is the Oligocene, which is 34 to 23, but I will refer it as 35 to 25 million years. The reason is that these numbers, which I'm referring to, they are easy to remember and also make the storytelling smoother. Oh, now it works. Okay, question. Anybody in the audience is living in Australia at the moment? Anybody? 10 seconds. Very well then. Oh my God. This slide is not functioning the way I anticipate to function. Welcome to Australia. Now, to those that have already been to Australia, those that work here, student here, or already visited Australia, welcome back. Now, Australia is big. How big is it? It is 7 million kilometers square. Compared to Malaysia, Malaysia is 300,000 kilometers square. Why Malaysia? Because I come from Malaysia and most of the audience here is from Malaysia. So I make comparison between Australia and Malaysia throughout this presentation. So that means Australia is 23 times bigger than Malaysia. 23 Malaysia can fill the Australian continent. Australia is old, and how old it is? It is 4.4 billion years old. It is as old as the Earth itself. The Earth is 4.6. 4.4 billion years old is represented by the detrital zircon crystal that is found at Jack Hill in Western Australia. Now compare that to Malaysia. Malaysian geology is only 500 million years old, represented by the Machichang Jerai Formation, also the Papulut Quartzite and the Dinding Schist. So how old is Australia compared to Malaysia? Australia is 9 times older than Malaysia. Because it is very old, most of the mountains that formed during those time has been eroded away. Australia is also flat. But to be honest, not all Australia is flat. As you can see here, in Western Australia, Mount Meharry is 1,200 meters high. In New South Wales, the highest point is Mount Zeel, 1,500 meters high. And South Australia, the highest point would be Mount Woodruff, 1,400 meters. But none of these highland reaches 2,000 meters. For example, our Mount Tahan and Mount Corbu, they are 2,200 meters high. So generally, Australia is flat. It is a splattered glass, and the road that travels around Australia will be flat, would be straight as an arrow. It's not only all flat, but Australia is also red. So according to Dr. Richard Smith and his team of geologists, they say that continental Australia is red since the Carboniferous 360 million years to 300 million years ago. Because in the Carboniferous, the oxygen in the atmosphere is 50 times higher than today, causing not only the biological evolution of giant insects and invertebrates, but also cause iron-rich rocks and soil in the outback to rust. Do you believe what Dr. Richard Smith said? Australia has been red since Carboniferous time, since 300 million years ago. It is not 1 million or 2 million years, but Australia has been red for 300 million years. Do you believe me? Anybody? Flat and red, Australia is hot. Hot because it is in the tropical zone. And it's also dry. 70% of Australia is dry, is semi-arid, arid, or desert. And because it is dry, it is uninhabitable. And how uninhabitable it is, the population of Australia is 26 million people. When you divide that by 7 million kilometers square, and you will get a population density of 3.5 people per kilometer square overall. That means all the 26 million people live in the 7 million kilometer square area. Population density is 3.5 kilometers square. Now we compare to Malaysia. Malaysia is small, and it is young. Geology only extends to 500 million years ago. And because it is young, it is mountainous, and it is green. Unlike Australia, Australia is red. And it's also hot. That's the only similar attribute between Malaysia and Australia. Malaysia is hot because it is in the equatorial zone, whereas Australia is in the tropical zone, and it is wet. Because it is wet, Malaysia is green, and because it is wet, it is populous. So how populous is Malaysia? Population of Malaysia is 33 million, and if you divide that by the area, 300,000 kilometers square, and you will get population density of 100 people per kilometer square. So it is actually not true if we calculate population density of Australia as an overall, because people do not live in this dry zone. If you were to consider only the habitable zone, that means the 30% of Australia, all this green part here, and then you will come up with a better and more accurate representation of the population density. But even that, the population density is very much less than of Malaysia. What you do here, the 26 million people in Australia, you divide that by the 30% area of 30% of the 7 million kilometers square. You divide the population with 30% of 7 million kilometers square, and you will get this figure, 11.5 kilometers square as the population density. Now, this is how Dr. Richard Smith summarized Australia. Australia is big, old, flat, red, hot, dry, and uninhabitable. I find this useful. It helped me understand what is going on in my daily life. However, not all of Australia is flat. It's old, flat, red, and dry. Only 70% is dry, as I mentioned. This part here. And 30% is green and habitable. So all the population of Australia live in this green zone. So we shall see what is in this green zone. Northern Western Australia, Northern North Territory, and Northern Queensland. These are the tropical savanna area. Tropical means 2 seasons, the dry and wet season. The dry season is hot, it's hot and dry, whereas the wet season would be hot and wet. Wet means rainy season. So it doesn't matter whether it is a dry season or rainy season, they are still hot. Savanna means grassland, and grassland that withstands of eucalyptus. Now we come to this part of Australia, which is the Daintree tropical rainforest. It is the oldest surviving tropical rainforest in the world, about 180 million years ago. So about 180 million years ago, almost the entire continent was covered by tropical rainforest. Almost all of Australia covered by the forest. So now question, what period is 180 million years ago? Any takers? Is it the Cambrian, Ordovician, or Silurian? 180 million years ago. If you answer, I'll give you a gold star. Anybody?
Precambrian?
Precambrian.
No. Again, the question.
Why? Is that Dr. Haley? Who answered that? Wow. I have
Me,
here.
Akmal. I'm a Dr. Riri student.
Okay,
Future
Akmal.
doctor,
Yeah, thank you. Thank you very much for your answer. Well, Zara, I got the answer here. It's Jurassic. That's brilliant. Exactly. 180 million years ago, it was a lower Jurassic. And as I mentioned earlier, Jurassic is the era Jurassic is the, sorry, Jurassic. Yeah, Jurassic is the period where Earth experienced a greenhouse. It was greenhouse Earth, Jurassic. Because it is hot, high evaporation, it's not only hot, but it's also wet. So because of the wetness, most of Australia here is covered with tropical rainforest. Also during Jurassic, it is the age of the dinosaurs. So there were millions of dinosaurs lurking around in the forest of, in the tropical rainforest of Australia then. So then I contacted Dr. Richard Smith again. I asked him, earlier you had said that Australia was red, and it was red for the past 300 million years ago. Now you're saying that Australia is covered with tropical rainforest. So how come? You know what his answer is? His answer, it doesn't matter what grows on the red soil. If it is red, it shall always be red. And I recall we have the Langoon red bed. Langoon red bed, Upper Devonian. That was 400 million years ago, and it's still red. And I recall the old red sandstone of Scotland, also Devonian, 400 million years ago. It is still red now. So that's true. Australia has been red since Carboniferous time, since 300 million years ago. By the way, Dr. Richard Smith is a geology educator for ABC, for Australian Broadcasting Corporation. Now, Mesozoic Jurassic was greenhouse Earth. It was hot and wet. As time crept forward, warming turned into cooling. By 35 million years ago, temperature plummeted, and modern ice age set in. Antarctica once again was covered with ice sheet. With less evaporation and less rain, climate became drier. Very interesting Antarctica is, during Carboniferous, 300 million years ago, Antarctica was covered with ice. Then during the Pliocene, the superheated Earth, Antarctica was green. It's covered with green forest. Then, 35 million years ago, ice start to cover Antarctica again. So Antarctica has a very interesting history of ice sheets. So by this time, 35 million years, the climate get dry, here, but that is not so to Australia. Australia, as it broke loose from Antarctica 35 million years ago and drifted northward, the whole of Oligocene was still tropical. And it wasn't until mid-Miocene did Australia begin to dry. So now, the tropical rainforest that once covered whole of Australia became grassland. And it wasn't until the Pliocene 5 million years ago, Central Australia was completely claimed by the desert. The tropical rainforest, then that once covered the whole of Australia, was pushed to where it is now, the Daintree tropical rainforest. It now covers just 1% of Australia. Yeah. So the whole tropical rainforest has now been pushed back to this place. Question, this is very interesting. During the Cretaceous Paleogene mass extinction, did all the dinosaurs went extinct? The mass extinction that wiped out the dinosaur and 80% of life on Earth. During that extinction event, did all the dinosaurs went extinct? That's my question. Any idea? The answer is no. Not all dinosaurs went extinct. The non-avian dinosaur went extinct, but the avian dinosaur still live with us. We are living with 10,000 species of the descendant of dinosaurs all over the world. 10,000 species of them. 800 species in Australia. Amazingly, the same number of species, 800 species living in Malaysia. They are around. The descendant of dinosaurs, they are all around us. Now, here at the Daintree tropical rainforest, you can find one of them, which look very similar to a dinosaur. It is the cassowary bird. You just Google, see how a cassowary bird look like. It will look like a dinosaur. I'm sorry, this slide is not functioning the way I supposed to function. Regardless, here we have a tropical savanna. This place is a tropical rainforest. Now below this, up to the boundary between Queensland and New South Wales, these are the subtropical climate. And in New South Wales and Victoria, the climate is temperate. Temperate means with 4 seasons. And here is the Australian Alps. Australian Alps has an alpine climate. It snows in winter, and there are also ski resorts in Snowy Mountain. This is Snowy Mountain, and this part is the Victorian Alps. Here is what we call the Blue Mountain. Tasmania, the temperature is maritime or oceanic, meaning wetter than temperate. And it also snows in winter, but only in the highland. With very rare occasion, do we have snow at sea level in New South Wales, Victoria, or Tasmania. But we have snow in the highlands. Now these 2 green patches, here and here, this is Perth, this is where I live. They are Mediterranean climate, meaning 4 seasons. The summer is hot and dry, whereas winter is mild and wet. It's not cold, just mild and gray in winter. So this is Australia. Where is Malaysia in Australia? It's here. Malaysia is in eastern part of Australia in terms of geology, greenness, and mountainous. West Australia, Archean, Middle Australia, Proterozoic, whereas Eastern Australia is the Phanerozoic, Cambrian to recent, the geology, and it's also much more greener than the rest of Australia, and yeah, it's also mountainous. The Great Dividing Range stretches from north of Queensland all the way down to Victoria. And the highest point in Australia, in fact, is Mount Kosciuszko. It's 2,200 meters. That is as high as our Mount Tahan and Mount Korbu, 2,200 meters. So this is Malaysia in Australia, Malaysia with tropical or temperate climate depending on where you live. If you live in Queensland, you will be tropical climate. Whereas if you live in New South Wales and Victoria, it will be a temperate climate. Note also, because I did mention Eastern Australia is Phanerozoic, Cambrian to recent. The geological history of Tasmania here extend all the way to Mesoproterozoic, but regardless, it is predominantly a Phanerozoic. Apology to those audience that have no geological training, but we just listen. Sorry about that. Just follow. Now, we cannot talk about Australia if we do not mention about First Nation people. The Australian respect the Aboriginal people, so we have to mention this when we talk about Australia. The First Nation people landed in this here is shown as in various artifacts that is found here in Kimberley, in Kakadu, and also Arnhem Dam. They landed here 60,000 years ago. There were no land bridges, so they came here by primitive boats. And 2,000 years, 20,000 years later, they have migrated to New South Wales, to Mungo Lake, and the remains is found as Mungo Man, dated to be 40,000 years. That is similar to our Homo sapien that is found in Nya Cave, Sarawak, also dated 40,000 years ago. So there's another similarity between Australia and Malaysia. Australia, oldest dated Homo sapien, 40,000 years ago, whereas in Malaysia, the oldest dated Homo sapien was also 40,000 years ago. Now, we cannot talk about Australia if we do not talk about the Great Artesian Basin. Yeah. It is one of the largest freshwater aquifer in the world. It is Australia's largest underground groundwater basin. It underlies some 25% of continental Australia. Now, in one of the webinar I attended last year, Dr. Evans, he told us he did a geothermal feasibility study in the Great Artesian Basin. But until today, there is no geothermal power station in Australia, just like Malaysia. And just like Malaysia, the net zero carbon target for Australia is 2050. Malaysia also net zero carbon target 2050. But until today, there is no geothermal power station in Australia. Here in the Great Artesian Basin, the aquifers are very deep, as deep as 1.5 kilometer, and the water are superheated. And when the farmers in this area, they pump up the groundwater, they have to cool the water in a reservoir. When the water is cool, only then they fed the water to their cattle. So, Dr. Hayiri, team student, would like to do to continue Dr. Edwards' work here in the Great Artesian Basin. Welcome. Another webinar I attended was from Dr. Max Meju. He introduced this cross-gradient multi-physics image technology. So maybe you can use his method to determine the potential geothermal sources in Australia. Just saying. All right. Next. Question here. This is the map of Australia. What are the geographical feature is regarded as an Australian icon? Anybody? You can see it in the map. Beside the Great Artesian Basin. Wow! Brilliant! I know. Yeah. Suraya Ayers Rock, yes. That's brilliant, brilliant. Wow. Ayers Rock, Abdul Hadnan. Yes. Thank you for your feedback. Yes, Ayers Rock, Uluru, yeah. But Ayers Rock is here. But the more iconic would be, thank you very much for your feedback, by the way. But the more iconic would be the Great Barrier Reef. The Great Barrier Reef is the world's largest coral reef. It is 2,000 kilometers inland. It consists of 3,000 individual reefs and 900 islands. So later on, we will refer to the Great Barrier Reef. Just one more point here before I leave this welcome to Australia segment. Just one more point. Despite being green and habitable, this 30% of Australia is still underpopulated. Here, look here. There's only 12 people per kilometer square. And it is underpopulated by all standards. If you see Nigeria, the population density is 250 people per kilometer square. China, 300 people per kilometer square in the habitable zone. China, like Australia, is like Australia. Australia is 70% dry, whereas China is 60% dry. In Australia, the habitable zone is 30%, whereas China, it is 40%. So just considering the habitable zone in China, the 1.4 billion people in the habitable zone of China, we come up with this population density, 300 people per kilometer square. And India, 400 people per kilometer square. If you compare this 100, 200, 300, 400, Australia is so very unpopulated. And people come, most of the migrants that came to Australia, they came for their Australia for the promised land. And also because their population is so high, their population density is so high. So most of the Chinese and Indian would live in Brisbane, Sydney, Melbourne, and also Adelaide, and a few in Perth. So to this promised land with inverted commas, professional, geologists, engineers, doctors, lawyers, or the non-professional, the cook, the drivers, the gardener, pet caretakers would like to come to populate Australia, you might do so, just contact her. And what you need is, you have to be talented, to be smart, hardworking, and determined. Or just plain luck. If you're lucky, you can get away with all this. Talent, smart, hardworking, determined. Just come here for free. So we come to next part of the presentation, that is on the brief introduction of geology of Australia. The continental Australia actually grew eastward. This part, as I have mentioned earlier, it is Archean, middle part Proterozoic, whereas the eastern part is the Phanerozoic. Phanerozoic means visible life. It means the geology is Cambrian to present. And if you to compare this to Malaysia, we have in the west coast of Malaysia, geology is west coast of Peninsular Malaysia. The geology is Paleozoic and Mesozoic, whereas the east coast of Peninsular Malaysia, geology is Upper Paleozoic and Mesozoic. Whereas in East Malaysia, geology is Mesozoic and Cenozoic. Sabah is entirely Mesozoic and Cenozoic, whereas Sarawak has some Carboniferous as well as Permian, but dominantly they are also Mesozoic and Cenozoic. So similar to Australia, the geology tends to get younger towards the east, and so does Malaysia. Malaysian geology also get younger towards the east. Just consider. Not everywhere it is like that. Now, between 2 to 1.8 billion years ago, the Nilgam crater collided with the Pilbara crater during the Capricorn orogeny to form a new continent called the West Australian crater. And then Northern Australia here formed the North Australian crater. And Southern Australia form the South Australian Craton. So we have the West Australian Craton, North Australian Craton, and the South Australian Craton. West Australian Craton, North Australian Craton, and South Australian Craton. So the West Australian Craton collided with the South Australian Craton about 1.7 to 1.1 billion years ago, forming a broad band of ancient alpine mountain range in this Albany-Fraser origin. And then the North Australian Craton got welded to the West and South Australian Craton about 1.3 to 1.2 billion years ago. And all this event occurred during the so-called boring billion, between 1.8 to 0.8 billion years ago. It is a period of continental construction when Western Australia, 2/3 of Australia, was made up. It is called, this is 1.8 to 0.8 billion years, is 1 billion, basically 1 billion. And it is 2 times the geology of Malaysia. 500 million years plus 500 million years, you get a billion. And the reason why it is called boring billion, because during that period of time, nothing seems to happen. There were practically no biological evolution, no extinction. The climate is stable. There's no greenhouse Earth, no ice house Earth. The chemistry of the atmosphere stable. Chemistry of the ocean stable. So it was pretty much boring, except for the continental construction that's happening during those periods. So this is 2/3 Australia. What happened to the 1/3? It has not formed yet. So beyond the Cambrian Tasman line, this line here stretches from Queensland to Victoria to Victoria. The entire eastern third of the continent had not formed. The eastern state of Australia was still mud at the bottom of tropical sea. Cambrian. During the Cambrian, this part of Australia was at the equator. Hedge. The sea is tropical. And also, I would like to think of this Tasman line as equivalent to our Bentong route suture, where the East Malayan block got sutured to the Sibumasa block during Triassic. So what happened to the third of Australia that had not formed? Yeah, what happened here? This is the 2/3 of Australia that has formed. This is the Tasman line. And offshore, we have this volcanic arc forming from the subduction of the sea floor under the then continental plate. So in between the island arc and old Australia. Mainland was a shallow sea that's filled with mud. It was filled with sand, mud, ash from the volcano. And as they thickened, they hardened into rocks. And they were also fringing of coral reef that formed limestone, while the glossopteris forest from coalfield that formed the coalfield in Queensland and New South Wales. So as these two plates constantly shunting, pushing into each other, every time they did so, fresh rock was pushed and shunted and piled up along the Australian mainland. So piece by piece, shunt by shunt, the highland of Eastern Australia, Mount Kosciuszko, and the Great Dividing Range, seen previously, rose from the sea, intensely folded and faulted. So a spoiler alert here. A spoiler alert for the coming caves and casts of Australia. In this part of Australia, Eastern Australia, the limestone is intensely folded and faulted. And you can only find that type of limestone in Australia, not the rest of Australia. So while Eastern Australia was assembling with the Carboniferous, this part is not formed yet. Australia was part of the supercontinent Gondwana, consisting of Australia, Antarctica, South America, Africa, the Arabian Peninsula, and Indian subcontinent. This is still Cambrian. Then the Indian subcontinent drifted from Australia along the Darwin Fault about 300 million years ago with the Permian. Here, India have drifted away, and so we are left with Australia, Antarctica, and South America. So before the Paleocene, before 65 million years, there were no marsupial fossil in Australia. Marsupial means mammal with pouch that carry the young, like kangaroo, koalas, and wombat. There were no fossil of marsupial in Australia before 65 million years ago, but there were fossil of marsupial in South America. So those marsupial that we find in Australia nowadays must have come from South America. And they came through what we call this trans-Antarctic highway. They would travel from South America through Antarctica onto Australia. Note, it was Paleocene. It was super greenhouse Earth. It was hot and wet. Antarctica was then covered with green forests. So here, Australia still attached to Antarctica. 35 million years ago, Australia drifted away from Antarctica, and Australia finally set free from the rest of the world, trekking northward at a breakneck speed of 12 centimeters per year. since 35 million years ago. So the timing, the direction, and the speed of isolation of Australia is drifting is significant for a couple of reasons here. The timing, 35 million years ago, direction, Australia is drifting northward, speed 12 centimeters per year. And knowing this is significant because now isolated and alone, Australian plants and animals began taking on their unique antipodian identity. Antipodian means Australian identity. They can only be found in Australia, not anywhere else, because Australia is now separated from the rest of the world. So there's nowhere they can go except for Australia. So we have these trees we call eucalyptus. And eucalyptus dominate the country with over 600 species only found in Australia. They are masters of adaptation. They can be found in the snowy mountains to the drought-stricken plains, and they are often inundated with prolonged floods, and they can survive in the punishing heat of a bushfire with bursts of new green growth. So that's why they are dominant, because they can grow in snow, they can survive in prolonged floods, and they can also survive in bushfire. The eucalyptus, or eucalypts. The genus name is eucalyptus. Also, because now Australia is isolated, marsupial, such as the kangaroos, wallabies, koalas, wombats, Tasmanian devils, bandicoot, numbats, Australian anteaters, sugar gliders, possum can only be found in Australia. Marsupial, those are the mammals with the pouch that carry their young. So are the monotremes, the platypuses. Monotremes are mammals that lay eggs. For example, the platypuses and the echidnas, the spiny anteaters, can only be found in Australia. So now the fact that we know Australia is drifting towards the north at this speed, so sometime in the future, Australia will cross the equator as it was half a billion years ago. Half a billion years ago is 500 million years ago. That was during Carboniferous. During Cambrian, as I told you earlier. Cambrian was the time when Australia was at the equator. It will again, Cambrian, Australia was at the equator. Then it drifted southward. During the Triassic, this town here, we call it Burke in New South Wales, Burke was at the South Pole during the Triassic. From Triassic, it drifted back northward until where it is today. So Australia will once again be part of another great supercontinent, a new world somewhere in the North Pacific, Pangaea Ultima. So that's end of part 1. So thank you very much for your attention. I think is it time? $11:13. Yes. That's the whole welcome to Australia and a brief introduction to the geology of Australia. So now what? Shall we continue with Q&A or we take a break from here? Dr. Ayuri?
Mr.
Okay.
Robbie, is it end of part 1, right?
Yes, it's end of part 1, yes.
Okay.
So
I
what
will.
will it be? Question answers or take a break?
Yeah, you can proceed with the Q&A session
Okay.
first, and then
Okay.
we the rest first lah.
Okay.
All right. So please proceed with the Q&A. Maybe participant have some question. Basically, I at Sungkai, as I mentioned, I need to join another event also. My PhD student, Mr. Akmal, will cover me, and up to him to continue or how. All right, Mr. Ramli, open to question first.
Any question from the floor?
Question, Mr. Ramli. Mr. Ramli?
Yes.
Yeah, can you hear me?
Yeah.
Yeah, Tan here, Tan.
Oh, Mr. Tan.
Yes,
Hello.
yes. Very interesting talk. You are a very good storyteller lah. Very good.
Yeah, very unfortunate because the slide key doesn't work. I have
It's
to
okay.
scroll the slide through.
Yeah, I
Doesn't
think
work that
I
way.
think
But
I think
anyway,
overall it's
get-
very good. Yeah,
Thank you very much.
very good
Thank you.
presentation.
Thank you
Congrats
very
lah.
much.
Yeah, very good story lah. Yeah. And just a quick question, just briefly, what's the geology of the ice rock, and how did it become one big lump in the desert? Ice rock, right?
Ice rock is Cambrian.
Yeah. What
It is-
type
it is-
what type of rock? What type of rock is it?
It is sandstone.
Yeah.
And can you see my pointer?
Yeah. Can.
All right. Okay. Ice rock is around here. It's also it's nearby the Katapuja. What call it? Massive. Ice rock, Katapuja. They are all limestone, and they came from these what we call the Pitman range. The Pitman range was formed somewhere during Precambrian, and that Pitman range eroded away to form the Ice rock and the Katakuja rock during the Cambrian time. So it was Ice rock is sandstone, and it formed during the Cambrian. Thank you for the question, Mr. Tan.
Okay. Thank you.
Mr. Ramli, and all the participants, we are currently reach our break time. Shall we proceed, or shall we have a break for 30 minutes before we start the session 2? Or how?
It doesn't matter with me. We can go on. What about the rest of the participants?
Yes, shall we ask some of the participants that have here? Can you respond in chat box if you are interesting enough? We can proceed with the session until we finish the lecture or the sharing session from Mr. Ramli.
Shall we break or we continue?
How about you, Mr. Ramli? Are you still energized?
Yeah, I'm very okay.
Okay, if Mr. Ramli feel comfortable to proceed on behalf of Dr. Hariri, I'm Akmal. We would like to continue this session, and we would like to welcome again Mr. Ramli to share and continue his thought and his knowledge about the geology of Australia. Please welcome, sir.
Thank you. Are you Dr. Ahmad? Akmal?
Yes, Mr. Ramli. I'm not yet doctor. I'm doctorate PhD student under Dr. Hariri.
Okay, thank
Yes.
you, Mr. Akmal.
One more one question from me, please.
Yes.
I see that you put our Sibumasu terrain. Did you put the paleogeography of our Paleozoic or the paleotectonic setting back then? Where is the Sibumasu terrain should be near to Australia continent?
Mr. Akmal, that is a brilliant question. Brilliant. I will cover that when I present the geology of Western Australia. Thank you. Thank you for that brilliant question.
Ramli, I think there are two questions in the chat box.
In the chat box, yes.
Yeah, there are two other questions.
From Nabil, how very is the Tasmanian Island with respect to the mainland until the geology ecology? Wait a minute. I'll give that a star. Thank you for the question. Tasmania, in terms of geology and biology, they are similar. Except that, as I told you earlier, in Tasmania, the geology is much older. It reaches to the Mesoproterozoic and Neoproterozoic. And also, interestingly, Tasmania is interesting because it was the last part. Antarctica was once attached to Australia. Can you see this pointer here? Navia, are you there? I'm answering Navia's question. The rest of the audience, can you see my pointer? Can you?
Yeah.
Okay.
can.
Yeah. So before 35 million years ago, Antarctica was attached to Australia. It's attached to the whole part of Australia. Now, Antarctica drifted southwards. It drifted in such a fashion that Antarctica drifted in the west first, but it's still attached to Tasmania. So this part has already been drifted. This whole part here has already been drifted. So what happened? Antarctica was still attached to Tasmania. And it remained attached to Tasmania until 35 million years ago, until Oligocene, until early Oligocene, when finally Antarctica break free from Tasmania, it break free from Australia. There was protrusion of dolerite being intruded into Tasmania. So you can find doleritic sea stack around Tasmania, and the highlands of Tasmania is also doleritic. And you can see this dolerite all over Tasmania. From Hobart, the capital here, you can see the dolerite islands and the dolerite sea state. So that's it in terms of geology. And biology, yes, it is similar. Biological wise, the geology, the biology of Tasmania is similar to that of mainland Australia.
Sorry to add, Mr. Ramli. As you said, we have similarities in geology and biology of this region, Tasmania and Australia continent. What
Yes.
are or what is some sort of example that you can give to us? Maybe about the kangaroos or any
Oh,
what is
yeah. Yeah.
any animals or specific
Thank
species?
you. Yeah, thank you for the question. Yeah, practically all the animals and plants that are found in the mainland is also found in Tasmania. In the mainland, we have eucalyptus. In Tasmania, also we have eucalyptus plants. We have the banksia, we have the casuarina, we have the mari, and we have whatever plant that is found in Australia, in the mainland, we can also find in Tasmania plant. Whereas the marsupial, interesting. In Tasmania, we have no koalas. Queensland, New South Wales, Victoria, South Australia, we have koalas. Whereas the Northern Territory, Western Australia and Tasmania, no koalas. As far as koala is concerned.
Mr. Ramli,
Other than that,
other question is about the plant varieties. Did we have some similarities in fern? As we know, New Zealand has they represent themselves as the black fern rugby team. How about Australia?
fern. I don't know. Ferns are everywhere. Fern in Tasmania, Victoria, and New South Wales, we have fern. Yes, they are the iconic species in this part of Australia. We have I don't know what species they are, but they are ferns. Fern in Tasmania, Victoria, and New South Wales. By the way, is that Akmal asking the question? Was it about the fern just now? Akmal, are you there? There's a question here by Zara. Other than animals, is there any? Oh, Zara asked, other than animal, is there any ferns that correlate the movement of the plate? Oh, no idea. Other than animal, is there any ferns that correlate the movement of the plate? I have no idea. No idea. And Suraya, I need to dig out for a moment, but I pop again soon. Thank you for the great talk, Mr. Ramli. All right. Thank you for the notice. Great presentation. Thanks for sharing.
I think the Miss No question is quite interesting, Mr. Ramli. Dear sir, you mind to share your thought on Zealandia continent, which is near to Australia continent?
Zealandia, I have no idea. Zealandia, New Zealand, Australia, Zealandia, New Zealand, and Australia. I have no idea. Thank you for the question. Yes, sir. Mind your thoughts on Zealandia continent, which is near to Australia continent. Yeah, that is most interesting question. Thank you. No, I have no idea about New Zealand geology. Dr. Ahiri, sorry team, I need to go for another event. Mr. Akmal will represent me. All right. Thank you for the mentioning that. So pretty much I just know about Australia and Malaysia. Malaysia is where, because Malaysia is where I come from, and Australia is where I'm living now. But yeah, interesting question. Thank you, no, about this Zealandia continent. And the question on the fern on the plates. Can you determine fern plates? Coloration movement? Zara, is there any, what about this fern and the plates? Any fern that correlate the movement of the plate? Would you like to elaborate that, Zara? Are you there?
Mr. Ramli, I think what Zara just wanted to ask is about as we make some sort of paleo, what we call it as the one who work on fossil paleontologists, they would like to correlate the fossil evidence such as what we have in Sibumasu that is equivalent to what we have in Canning Basin, Australia, some sort like that.
Oh, I see. I see. Yes.
That maybe can be related from sedimentology point of view.
I see. Thank you very much for the explanation. Yes. No idea. This pollen. No idea. By the way,
do you find it quite a surprise or quite hard question for you?
No, I just know the gender geology. The gender geology.
Yeah, our participant already go through beyond advanced one.
No idea. Sweetie, you're still there? Mr. Velu, are you still there, Mr. Velu?
Hello?
Mr. Velu?
Yes, I'm still there. Yeah. This is Sweetie, Mr. Ramli.
Who's that?
Sweetie.
Oh,
Sweetie
Sweetie.
Lee.
Hello. So far. So it's
Yeah.
still, thank you for coming over. I'm very sorry for these technical glitches.
It's
For
okay.
the
It's really nice
presentation.
sharing. Thank you.
It doesn't go the way I expected it to go. Not even the sharing. Number one, the sharing of the slide earlier on. But then as the presentation go, the slide doesn't move the way I want it to. So very sorry.
It's okay. It's interesting. I can learn something from you.
Oh, yeah. All right. Thank you very much.
Thank you. Thank you very much for sharing.
All right. Thank you. Thank you. Mr. Value, are you there? Are you still there? Mr. Value is from Malaysia. He is my best friend. Okay, what time is it now? We're supposed to restart 12 o'clock. It's almost 12.
Mr. Ramli, I can see the numbers of participants already lessened.
Yeah.
Shall we continue with your presentation, or because we can finish it early, seems currently in Malaysia is 11:50. 11:50 a.m. here. I think most of the people will take a break soon for the lunch hour. So shall we finish this earlier? So we can give
Yes, thank you.
opportunity to others for their time.
But the thing is that they left because they anticipate that the presentation will start at 12.
Can please you can maybe you can unshare and share it again?
What is the slide?
The slide, yes.
Okay, let's see. Now the thing is that I can't even make the zoom to expand. I just see my face here. But how to zoom the expand? To expand the zoom. Ah, now this is good.
Okay, Mr. Ramli, I can see your slide here. Brief introduction, the geology of Western Australia. I think the same as yours.
I think it's mine. Okay.
Okay, part 2. Okay, that's better. I think
And
you can exit the presentation mode. Just use this mode.
can you see that part 2?
Alright.
Now
You can
this
see.
mode is better, yeah. But I cannot see the zoom. But can you see my face?
Yes, Mr. Ramli, we can see your face.
Okay. (11:56), 4 more minutes. This looks nice.
All right, Mr. Ramli and all the participants, thank you for your time and for your loyalty towards JSM sharing session. Now it's 12 a.m. 12 p.m. in 12 p.m. in Malaysia time. So we would like to proceed with our second session, which is the sharing session of Ilgaran Kraton and Boya Quarry from Mr. Ramli. So I would like to invite Mr. Ramli to continue his sharing session.
Mr. Osman, thank you very much. So now we proceed with part 2, the content of presentation. So far, part 1, we have covered welcome to Australia, and then a brief introduction to the geology of Australia. We come to part 2. That will be on a brief introduction to the geology of Western Australia, a brief introduction to the geology of southwest of Yilgarn Craton, and appraisal of the geology of Boya Quarry, Western Australia. A brief introduction of the geology of Western Australia. So we look into the Bonaparte sedimentary basin here, the Odd sedimentary basin, the Canning basin, as well as the Carbon sedimentary basin. So the Bonaparte basin, sedimentary basin, it is oil and gas offshore, and currently a number of oil and gas fields are still producing oil and gas in the Bonaparte basin. Odd basin, it is a large sedimentary basin in Western Australia as well as Northern Territory. Then we have this Canning Basin. 7, Canning Basin is oil and gas onshore. So 10 years ago, I looked at the official Australian government report saying the Canning Basin is underexploited. Recently, I looked at the same report. They have updated the report, and it still says the Canning Basin is underexploited. So you can Google and look for yourself. So maybe interested petroleum geologists, geophysicists, a student might like to come here to undertake exploration of the Canning Basin. Just saying. One of the webinars I attended last year, Atilia Basharuddin reported there were 3 conodon specimens from early Ordovician from Hutan Aji Perlis. They are also found in the Imano Formation Canning Basin here. And these are the conodon specimen that she found. And curious, I look into the Paleozoic geology of Peninsular Malaysia. So what is happening is that a link, the geology of Australia, in particular the Canning Basin, with that of Malaysia. And I come up with this, most interestingly. This is during late Carboniferous. I took this from Hutchinson, 1989. This is Australia, Antarctica. And look, Bonaparte Basin linked to the Indochina terrain, what called this, the East Malaya block. Canning Basin also attached to the East Malaya block, whereas the Carnivore Basin attached to Langkawi. And this is Phuket. This is the Sibumasu block. It was during the early Permian. It was during the Permo-Carboniferous 300 million years ago. During the Permo Carboniferous 300 million years ago, Antarctica was covered with ice sheet, and much of the southern Australia was covered with ice. In fact, it was the average global temperature was -4 degrees. It was during the Karo Permo-Carboniferous Ice Age, where there were 8 cycles of glaciation and interglaciation throughout the Carboniferous and Permian, operating the same way as the Quaternary Ice Age. So we have the cycles of glaciation and interglaciation. 8 of these cycles were in the Carboniferous, whereas 2 of these glaciation and interglaciation cycle in the Permian. So it was ice house Earth then. A lot of ice. So now this is the question. Any idea what happened in Langkawi during the Carboniferous? 360 to 300 million years ago.
Shall I answer your question?
Oh yeah, is this Atman?
Yes, Mr. Ramli.
Oh, okay, thank you. Yeah.
So back then in Sibumasu terrain, we also having the same paleoclimate as Australia. So we received the late Paleozoic Ice Age sediment. So what we call as the glaciogenic sediment. So the same cycle or the cyclic of the climate change that have been recorded is preserved in our sediment. So we have the Permian or Singa formation that have the dropstone inside our host rock, inside our black shale in Singa formation.
Mr. Akmal, that is brilliant answer. Correct. In the Singa formation, during the Carboniferous, Singa formation was deposited. During the deposition of this Singa formation, there were layers of dropstone in the formation, and this dropstone, they were dated to be 1 billion years. That is Neoproterozoic during the Tonian era, Tonian period. I mean, so yes, so this dropstone would have come from Australia. Thank you, Mr. Akman. So now we go to the Carnivore Basin, as understand here. It is also oil and gas, onshore and offshore. And we cannot mention about the Cannibal Basin without mentioning the Barrow Island, because significant oil and gas fields in the northern Cannibal Basin are located around this island. So every time last year when I attended those webinars, we were talking about oil and gas, geophysics, oil and gas. So I was thinking about this Bonaparte Basin, about this Cane Basin, in particular about the Cannibal Basin and Barrow Island. These are where a lot of oil and gas can be found. So now we come to the Perth Basin, number 11 here. Perth Basin is an offshore sedimentary basin extending about 1,300 kilometers along this Australian margin. It was formed during the rifting of the Australia and Greater India in the Permian to early Cretaceous along the Dunn Fault. So Greater India rifted away from Australia, forming a basin that is to a depth of 15 kilometers. Overlying the Perth Basin is the Swan Coastal Plain, and we shall see and discuss later on the Swan Coastal Plain. And Perth Basin is also a resource for hydrocarbon. Then we come to the Kimberley province, the Kimberley Plateau, and what can we find in the Kimberley province? You can find the Great Barrier Reef. It is the Great Devonian Barrier Reef, which is equivalent to the present-day Great Barrier Reef, except that the marine fauna are different. During the Devonian, we see Devonian soft and hard coral, also Devonian fish and Devonian marine invertebrate. Whereas in the Great Barrier Reef, we see present-day marine life. Also in the Kimberley Plateau, there is a GoGo station here, and around the GoGo station, there are limestone nodules, and these limestone nodules, they contain Devonian fish. Also in Kimberley Plateau, there is the Devonian Honolulu National Park, the Bugger Bugger Range, the Diamond Mine, and spoiler alert for the coming caves and karsts of Australia. The limestone that is found in this in the Kimberley, as well as in the northwest Australia, the paludrite limestone, they are flat. Unlike the limestone in East Australia, they are folded and heavily fractured. Limestone here and the limestone here, they are flat. So there are two contrasting geology for the cave and karst of Australia. One is very much folded and fractured, whereas in northwest Australia, the limestone are flat. Number 4, the West Australian crater. This I already discussed. The Pilbara collided with the Yilgarn Craton collided with the Pilbara Craton, forming the West Australian Craton. And then we come to Lewin Naturalist Bridge, number 5 here. To save time, I shall not elaborate. Just can read from the note I left. And then the Albany Fraser origin, this area 6. Already discussed. The West Australian craton collided with the South Australian craton during 1.7 to 1.1 billion years ago, forming this origin. So now we come to the geology of Southwest Yilgarn Craton. So Southwest Yilgarn Craton is an ancient stable landmass of very rock type that occupies much of southwest part of Western Australia. So this is the Yilgarn Craton, and in the board is the Southwest Yilgarn Craton. And large, this is the Southwest Yilgarn Craton here. This is Perth, and this is Boya event, where the Boya Quarry geology, which I'm going to elaborate later, is. So Southwest Yilgarn Craton, the rock type would be the greenstone, as can be found in Wellington, here in the wheat belt. Also the metasediment, the schist and the gneiss, which actually cover most of Southwest Craton, Yilgarn Craton. The gneiss and lignite here. The monzonite diorite in the Albany Fraser province, and the granitoid. Also, which is not part of the Yilgarn Craton, but it is in this map, just to mention, the Proterozoic rocks, the granitoid and gneiss and lignite are found in the Lewin block. The metasedimentary cover here and here. This is Stirling Range. Highest point is 1,000 meters. Mount Baker is actually a town. It's about 300 meters high. And the Phanerozoic rocks, that's the rock from Cambrian to present day, is found in the Perth Basin, as I mentioned earlier. This is the Perth Basin, but it is again not in the Southwest Yilgarn Craton, but this is in the map, so I just mentioned it. So what happened in the Southwest Yilgarn Craton? The older schist and gneiss, as I said earlier on, they covered much of the Western Southwest Craton. But what is being exposed now is the teetering metamorphic belt, which is 2.9 giga-annum ago, and the Jimperding metamorphic belt, 3.1 billion years ago. This is the teetering metamorphic belt, and this is the Jimperding metamorphic belt. Probably they were part of the supercontinent of Albara in the Archean. Then we have, as I said earlier, the metamorphic rock were intruded by voluminous granitic rock, the granite at Boya Quarry is about 2.6 giga-annum, probably part of the supercontinent Conolent. Not shown here are swarms of Mesozoic, are swarms of Meso and Neo Proterozoic dolomite that intrude into the granitoid. It's not shown in this map, but these swarms of dorite dikes, they are actually very prominent. You can see these swarms of dorite dike at the mountain quarry, at Boya Quarry, and Staten Quarry, and also much of the Perth Hill around here. And they are very dominant, these swarms of dorite dike. So the presence of these sheets, gneiss, lignite, greenstone, granitoid, and dorite dikes indicate that the craton has been subjected to continental collision, subduction, and drifting throughout the Archean and Proterozoic eon during the assemblies and breakups of the supercontinent Wabbara, Kernolan, Luna, and Rodinia. So last but not least, I'm to mention about the Darling Fault. This is the Darling Fault. It is a major structure that runs north-south for over 1,000 kilometers. It formed the east margin of the basin. Rift Valley that started 300 million years ago. So when India drifted away from Australia, it drifted along the Darling Fault. But some people say the origin of the Darling Fault was some 2.6 billion years ago when Yiga Craton was probably part of the supercontinent Kernolan. So Darling Fault, the origin of which is 2.6 gigaannum, but 300 million years ago, it was reactivated. So now this is the Boya event. Registration at campsite. So participant has to register at this campsite here. And I'm talking to Gwen. The background, this is the dolerite, the younger dolerite dike, the older dolerite dike. They intrude into the granite, the coarse grain granite. So this is the briefing I gave. So we made 5 stops. First stop was the Precambrian rocks, the coarse grain granite, this one here, the non-porphyritic dolerite, here, this one, and the youngest porphyritic dolerite, this block. The second stop was at a shear zone. Third stop, shear margin. Fourth stop on the xenolith. And finally, lateritic profile. So taking the participant to 2 trip stops. So this is the second stop at shear zone. What is being sheared is the coarse grain granite. These were the participants taking note of what's happening in the shear zone. And here's the question. Any idea what trees are these? You can see the trunk very distinctive and the leaves, they're very distinctive. Trunk, leaves. Any idea what tree are these? Question. 10 seconds.
Is it eucalyptus or acacia?
Oh my God. Is that Akmal again?
Yes, yes. Mr. Ramli.
Yeah, you're brilliant. So brilliant, Akmal. Yes. They are eucalyptus. So They are eucalyptus. Chances is that when you see trees, they are eucalyptus. 70% of the trees in a natural stand are eucalyptus. And if you come to Australia, the only one tree that we have to know is the eucalyptus. Yes, yeah, all right. Thank you very much, Mr. Akmal. Now, participant taking notes at shear margin stop. Recapping the differences between shear zone and shear margin. We shall discuss this later on. And then explaining the formation of porphyritic dolerite and xenolite. Now explaining the formation of lateritic profile. Recapping what's happening so far. It's very difficult for them. Most of them have no geological knowledge. And general discussion with participants. And last but not least, acknowledgement. I would like to acknowledge Celestra. She's the photographer of the event. She took about 200 photos. What I've just shown you were maybe 5% of the photos. And also would like to express my gratitude to Eve. She was the co-organizer of the event. Wayne is just a participant of the event. He's working in the copper gold mine in Papua New Guinea. Now, what we're seeing here from Boya Quarry, looking southeast into the Precambrian Valley Plateau. This is what you see. The laterite caps, brown, and you can also see rock outcrops here. The gneiss, the schist, the magnetite, and of course the dorolites. So it is such a privilege to be here to experience the Precambrian geology of the Darling Range or the Darling Plateau. Geologically speaking, it is the Darling Plateau, but people often refer it as the Darling Range. So now looking west from Boya Quarry, this is what we see, the Precambrian Darling Plateau, the Darling Fault that runs through the area, 1,000 kilometers, that stretches 1,000 kilometers north-south. Then we have this Pleistocene ridge hill shelf, the Swan Coastal Plain, Quaternary, Pliocene and Holocene. Pearl CVD, we're going to discuss about Pearl CVD again later on. Pearl CVD is on Tamala limestone. And far in the background is the Indian Ocean. So the Precambrian rock at Boya Quarry, they are the coarse grained granite, non-porphyritic dolerite dike, and porphyritic dolerite dike. Coarse grained granite composed of microcline, sodic plagioclase, quartz, biotite, and they are 2.6 billion years old. No archaea. Now the porphyritic dolerite composed of calcic plagioclase, pyroxene, age 1.5 million years old. The medium grain porphyritic dolerite composed of calcic plagioclase, pyroxene, white plagioclase, phenocryst. Here, And the age range from 750 to 700 million years ago during the new Proterozoic era. Then this is the shear zone, Boya Quarry. The outcrop appears to be made up of broken pieces of parallel slab, like slabs of slates. And what is being sheared is the coarse grain granite. It was being sheared. It was probably caused by the movement of the Darling Fault 2.6 billion years ago, while the supercontinent Canolian was assembling. Sheared margin at Boya Quarry. Shearing of the granite and phosphoric dorolite caused the myolonite, which is a pulverized material, to form. They form by intense shearing and grinding of the two rock masses. And then the xenolith, the dorolite, the xenolith, close up of the coarse grain granite xenolith. And then the lateritic profile. This laterite form above the granite bedrock, the subrock, and the subrodif. Here, the lateritic profile form over doleritic rock, doleritic dike. This is the subrock layer. So you can see here the contrast of lateritic profile in terms of the color. Lateritic profile developed over granite rock. They are light color, light orange, light gray, whereas the granitic lateritic profile from over dolerite bedrock, they are deep red in color. So, note also on the present day flora and fauna, as Mr. Akmal mentioned, these three are eucalyptus. Chances of that they are eucalyptus trees. Also note there is a shrub here. These are three grass trees. These grass trees, they are food and grass tree. They're food and medicinal plant for the Aboriginal people. So we have the eucalyptus, we have the grass trees or the bulgur, and once in a while, depending on the food source in the area, you can see what we call the descendants of the dinosaur flying over looking for food. You will see the black cockatoo, the red waterbird, the Australian magpie, and the really wet-tailed. And often you can see kangaroo hopping around in this area. So you can see the birds, you can see the kangaroo, and in the soil, there are soil microbes. Now, this is the weathering profile, or what you call the lateritic profile. This is not the soil profile. This is a weathering profile. The weathering profile form over fresh bedrock consists of the regolith, the saprolith, and the pedolith. The saprolith consists of saprock and saprolite, whereas the pedolith consists of the arenation zone, the Moffat zone, and the lateritic crust. On top of that is blue soil. So what happened from Oligocene to early Miocene, 35 to 15 million years ago? Australia was still tropical. It is still hot and it's still wet. And under this hot, wet condition, the laterite formed during Oligocene to early Miocene. And at Boya Quarry, the lateritic profile, they were truncated, meaning what we can see above the granite bedrock, we can only see the sap rock and the saprolite. The rest has been eroded away. Above the dorolite and dike, we can only see the sap rock. The rest of the layers has been eroded away. So at Boya Quarry, the lateritic profile, they are truncated. Oh, nice. It's not working, still there. Okay, to the Australian, laterites are very important because of their economic significance. You can find bauxite in the laterite, as in the Darling Plateau, Western Australia. You can also find iron ores in the laterite, as in Mindowi, Western Australia. Road material, building material in the Darling Plateau, Western Australia. Nickel, cobalt, and scandium in Greenville, Queensland. The rare earth element at Mount Weld, the rare earth element at Mount Weld mine, they are being exported to Lynas, Malaysia, in Gebeng, Kuantan, Pahang, for refining. Clays and kaolin are found in Pratland, Western Australia. And secondary gold can be found in Wellington, Western Australia. So I got a question here. Do laterites in Malaysia has any economic significance? Suraya, any idea? Laterite in Australia, there are many. We have bauxite, iron ore, building materials, rare earth element, kaolin, gold. In Malaysia, do laterites in Malaysia has any economic significance? Oh, sweetie, thank you for your response. I asked about the trees just now at the share zone, and you mentioned camphor tree. Yes,
we have here our laterite in Malaysia, especially in Peninsular Malaysia, we have the REE. Same goes to what you have there.
REE.
Yes, yes.
Ah, thank you for feedback, Mr. Akmal. Yes, there are many uses. In fact, there are a couple more. They have been used in the cement factory. They are also used in the as a building material. But also, the laterite in Malaysia produce iron ore. So in 2012, when I was in GNG, in one of those monthly gatherings, I presented this. In Malaysia, there were 103 iron mines in Malaysia, produced 12 megaton of iron ore per year. Now, during that same period, one iron mine in Western Australia produced 15 megaton of iron ore per year. So one iron mine in Western Australia produced more iron ore than being produced by 103 iron mines in Malaysia. The reason was the iron ore that were mined in Malaysia, they are found in laterites. And iron miners, there are small iron mines, laterite iron mine all over Malaysia. So now we come to this schematic cross-section. West to east. From Perth, this is Perth, to the Darling Plateau. Darling Plateau covered with laterite cap. The Ridge Hill Shaft is in the Pitman zone. Pitman means foothill. You get a conglomerate and laterite here. Pinjara Plain, there are alluvial sand, silt, clay, loam, Basildine dune system, Aeolian quartz sand, and the Spearwood dune system, where Perth City is on. They are what you call, consists of lime, sand. So we have a lot of soil here. So maybe Mr. Tan and team, Atira student, like to study our soil. There are a number of engineering geology consultancy here in Perth. Just saying. Regarding this Spearwood dune system, the soil is limey quartz. That sand contains seashell. And this limey quartz soil, they come from the Tamala limestone, the Cacarinite, the Aeolian Cacarinite that form the Tamala limestone. And Tamala limestone is of Pliocene in age, specifically from middle Pliocene to upper Pliocene, from 775,000 years ago, not million, 775,000 years ago to 12,000 years ago. That's the Tamala limestone. And a spoiler alert for the cave and karst of Australia. The limestone that is found above this Perth basin is between 775,000 to 12,000 years ago. That is less than 1 million years ago. Any idea what is the oldest, what is the youngest limestone we have in Malaysia? Limestone above the Perth basin is less than 1 million years. Yet, they form spectacular caves, as can be found in the Crystal Cave north of Perth, and the Lake Cave, Jewel Cave, and Mammoth Cave in Margaret River. They form spectacular caves, and they are only less than 1 million years.
Ramli, sorry to interrupt.
Yes.
Ramli,
Yes.
where is Perth on
Perth is
this cross section?
Here, it's just here.
So it is on the dune system, yeah? Dune system.
It is on the, it's on the limey quartz sand, which is above the Tamala limestone. And of course, limestone, sinkhole, yes. We get sinkhole in Perth.
Yeah. So what's the folder rock underneath this in the cross section? The folder rock is what?
And these are the the Permian to Cenozoic per-basin rock.
Yeah, what sandstone, shale, or metamorphic, is it? Or something
No, they are sedimentary. They are
sedimentary.
all sedimentary, yes.
Okay. Yeah.
They are all sedimentary.
Okay.
And the oldest would be of the Permian age, as I told you earlier, when India drifted away from Australia, it drifted away and formed this drift valley. And into this drift valley, we get the Permian to Cenozoic sediment.
Thank you. Thank you.
Yes,
you.
thank you. Thank you for the question, Mr. Pat. From the what I call this the sediment of the Perth Basin. Now, here in the Perth Basin, the caves are of dual system, very young, very beautiful cave. These I'm talking about as becoming as spoiler alert for the cave in Castle Australia. I will talk about the Paleozoic limestone of East Australia. They are very, very much folded and fractured. I already talked about the Paleozoic limestone in Southwest Australia. They are flat. Now I'm talking about the limestone in the Perth Basin, which is very young, less than 1 million years ago, and they form in dunes in Kamala limestone. And as for Southern Australia, the limestone are flat and they form in tertiary and quaternary limestone. The cave and karst of Australia is more than just stalactite and stalagmite. The cave and karst of Australia is just like the plants and animals of Australia. They take a unique anthropogene identity, just like the kangaroo and the koalas and the wombat. They are very unique, just to mention. So we come to the geological history. Coarse grain granite formed 2.6 billion years ago. And this granitic magma was injected into the earth crust many kilometers below the surface during the formation of the supercontinent Kenolan. And after that, shearing of the coarse grain granite probably occurred during the assembly of the supercontinent Kenolan. And then about 1.5 billion years ago, a mafic magma was injected into the solidified granite rock. As a result of increasing fracturing of the earth crust during the breakup of the supercontinent Luna, this magma intruded along the fractures and joints in the granite to form dikes of non-phosphoric dolomite. Then 1.3 to 1.3 billion years to 750 million years ago, the supercontinent Rodinia assembled. Between 750 to 700 million years ago, phosphoric dorite dike intruded along fractures and joints in the coarse grain granite. And this non-phosphoric dorite dike formed during the breakup of the supercontinent Rodinia. At the same time, xenolith of coarse grain granite was included into the phosphoric dorite dike. Then we have supercontinent Penutia assembled between 600 to 550 million years ago. Then the assembly of the supercontinent Penutia probably caused this sheared margin, as we saw earlier on, between the coarse grain granite and the porphyritic dolerite dike. And after that, we have uplift and erosion of sediment cover during the Paleozoic and Mesozoic. And the laterite profile formed during Oligocene and early Miocene. Erosion of lateritic profile that formed during Oligocene and Miocene resulted in truncated lateritic profile as seen in Boya Quarry, and finally communities of present-day plants, animals, microbes that colonized the saprolite soil. These are full of text. So what I do here is to transfer the geological history in the graphic form. This is much more appealing, I believe it should be. During the Archean, the Val-Bara supercontinent formed, then the Conolan supercontinent, Neo-Archean to Paleo-Proterozoic. Then after that, the Luna supercontinent, Rodinia supercontinent, Pannotia supercontinent. This Pannotia supercontinent break into Gondwana in southern hemisphere and Laurentia in northern hemisphere. So later on, Gondwana collided with Laurentia to form Pangaea, and by middle Jurassic, Pangaea break up into the landform that we recognize today. So what happened in Boya Quarry? Shit, it doesn't work again. So I have to scroll. Okay. So in Boya Quarry, the granite formed at 2.6 billion years ago, while Quinolan supercontinent was assembling. Then we have shedding of the granite during the assembling of the supercontinent Quinolan. Then we have the non-porphyritic dolerite. This is the older dolerite formed at 1.5 billion years ago during the breakup of the lunar supercontinent. Then the porphyritic dolerite with the xenolith formed during the breakup of the supercontinent Rodinia. And the shear margin, we see the shear margin between the granite block and the porphyritic dolerite block formed probably during the assembly of the supercontinent Pannotia. So we have uplift and erosion during this Paleozoic and Mesozoic era. And then finally, laterization event took place during the Oligocene to Middle Miocene. The climate in Western Australia then was tropical, hot and wet, that formed this laterite. And then finally, we have the colonization of the present day flora and fauna. From here on, the breakup Pangaea will assemble again in 250 million years from now to form the Pangaea ultima that I have mentioned earlier. So these are the references I used for this presentation. Summary of presentation. Part 1 is on welcome to Australia. Brief introduction to the geology of Australia. Part 2, brief introduction to the geology of Western Australia. Pre-introduction to geology of Southwest, Legal Creighton, and finally the appraisal of geology of Boya, Western Australia. So thank you for your attention and hope to see you again in the next webinar. And I hope for the next webinar, I'm more familiar with this sharing and managing these slides. So thank you.
Okay, thank you very much, Mr. Ramli Muhammad Osman, for your wonderful presentation. I think it is very interesting. I open to the floor if there is any question from the participant. Please leave your comment in chat box or you can ask directly via your microphone.
So I have a couple of questions here in the meeting chat. A question from Abdul Hanan. Over the cross-section area, can we see different tree types as well? Cross-section area, can we see different associated with different geology? So, cross-section. Which cross-section is that? Mr. Abdul Hanan? Over the cross-section, can we see different tree types as well?
The
Oh,
cross section.
this, maybe this one here?
Yes, that's one.
Yeah, yes, of course. That's right. And lateritic soil, as I said, they are predominantly eucalyptus all the way the section, eucalyptus. Of course, we have other trees like what do you call this? Banksia. Banksia is also a fire-resistant tree. We have Banksia. We have this sheer oak, the Casuarina trees. We have the Mari trees. We have these peppermint trees. We have acacias, yes, acacias. And we have plane trees. There are many. There are many. But whatever it is, the eucalyptus, they're all there.
All right. Very interesting when you combine both biology and geology. Very interesting,
Yeah.
Mr. Ramli.
Now, where's the chat just now? Okay, so what's this? The form. Oh, dear, kindly fill up the attendance form.
Yes. Before we end our session today, I would like to ask all the participants to fill in the attendance form as per shared in our chat box. You can click on the link and you fill in your name and your institution and your phone number. Later on, this will contribute to your CPD, which will carry 1 CPD point.
Thank you, Sweetie Lee, for coming over.
Okay, before we end, I think there's no more question. Mr. Ramli, anything?
Yes.
Okay, I've talked about the CPD and the attendance form. I would like to thank, on behalf of GSM, Geological Society of Malaysia, I would like to thank Mr. Ramli Muhammad Osman for this lovely sharing session of our webinar.